Okay, so we're going to continue on with conversions. I'm going to kind of incorporate the prefix ladder that we learned a few days or last week. So let's see, how many of you remember your prefix ladder?
I know it starts with mega.
Mega, okay. So what's the symbol for mega?
Big M.
M. And then
That's a kilogram.
kilo. And mega is 6. And then kilo is 3. Then the base unit. And then what comes next?
Deci.
Deci, excellent. That's 1. What's after deci? Centi is 2. Milli is 3. Micro is 6. Nano, 9. Good. Okay. So we can use this prefix ladder to generate conversion factors so that you can have a nice block to put, like 1 kilogram is 1,000 grams. So you can have that in your pocket as a tool. So 1 meter, is meter a base unit or does that start here? It's a base unit. Okay, so 1 meter equals how many centimeters? So to get from the base unit to centi, I'm going to move 2 to the right. So 1 meter equals 100 centimeters. So now you have this conversion factor. And you can always generate these conversion factors if you just memorize the table. So, depending on what your solution map looks like, what you need to get converted, then you can use this. All right, so 1 meter equals how many nanometers? 1 billion. Yeah. A lot of zeros. All right, 1,000 grams. So we're in our base unit. We want to get to kilo, so we're going to move 3 to the left. Yes. So 1, 2, 3. Now, how many significant figures am I going to put here? 1. So just 1. Good. Okay. 1 meter equals how many millimeters? 1,000. So we're starting at the base unit. We're going to get to milli. So we're going to go 3 to the left. 1, 2, 3. So 1,000. Good. And then 1 megameter is how many meters? I'm starting off at mega. Trying to get to the base unit, so 1 million, yes. And then lastly, 1 meter equals how many micrometers? Meter to micrometer, 1 million. So 6 to the right. Right. So we can always generate these conversion factors based on this prefix ladder, which is nice to have. So if you're asked a question, how many grams are in 125 milligrams, you can do it 2 ways. You can move the decimal, or you can make it into a conversion factor method. So you're given 125 milligrams. You're trying to find how many grams. So if we do this with a solution map like we've been working on, we'll start out in milligrams and go to grams. So our starting quantity would be 125 milligrams over 1. And then we would use kind of this conversion factor. But our base unit isn't meters, it's going to be grams. So we're going to have 1,000 milligrams, 1 gram. So 125 divided by 1,000 is the same as moving the decimal 3 to the left. So you end up with 0.125 grams. So with this type of problem, there's really, I mean, you can move the decimal. It's not a big deal.
Would you have to do sig figs on that?
Sig figs, yes, always sig figs. And your given has 3 sig figs, and your answer has 3 sig figs. Because that 0 right there doesn't count. So on number 4, you can see how using the prefix ladder, making it into conversion factors, is helpful. So let's just go through and sort this. The sleeve of a shirt is 20 inches long. How many millimeters is the shirt sleeve? What are you given?
20.0 inches.
Given 20.0 inches. And what are you asked to find? Millimeters. Good. So you're asked to find millimeters. Okay. Where are our conversion factors? Now there's some at the table at the top. Look at that little box at the top. Do you see one that we could use here?
Inches to meters.
Inches to meters. It's a good one. Okay, inches to meters. So I'm going to write conversion factor 39.4 inches, 1 meter. What are some other conversion factors?
2.54 centimeters to an inch.
2.54 centimeters to an inch. Any other conversion factors that we would use? If you can, you're welcome to close that door. We could use some from our prefix ladder. Inches to millimeters, so meters to millimeters. So 1 meter is 1,000 millimeters. And then going from centimeters to millimeters if we go this route. So in 1 centimeter, 1 centimeter, how many millimeters are there? 10. Good. So we have 2 possible solution maps. So we have start off in inches, go to meters, go to millimeters. Or we have inches to centimeters to millimeters. So 2 possible ways to go about that. Okay. How would we show our work?
Are we using system number 1 or system number 2?
Whichever you like better. Yeah, so it's up to you.
Do inches to centimeters.
Inches to centimeters? Okay. So we're going to start with our starting quantity, right? Then 20 inches over 1. Now, an easy mistake to make on this problem, and I see this a lot, students will just write 20. No decimal, no point 0. So be careful on that. Make sure you copy down everything exactly as you see it, as it's given. Okay, 20 inches. Then we're going to have our conversion factors. How will we have them lined up? We're going to go with this. This is A.
Centimeters would be on top and then inches on the bottom.
Centimeters would be on top, inches on the bottom. Excellent. Now what do? If we stop here, we're in centimeters.
And then we need to cancel the centimeters and convert them to millimeters.
Good. So 1 centimeter, 10 millimeters. So now we're in millimeters. So in your calculator, you're just going to multiply across 20 times 2.54 times 10. And what do you get? 508. Millimeters. Good. Now, how many sig figs should we have? 1?
No, we separate.
3. Why 3?
Because the 0 behind the decimal is a significant number, row number 30.
Yes. Good. So this is 3 sig figs. So our answer has 3 sig figs. Yes.
But if we use the rules of multiplication one, though, isn't it 3 times 3 would give us one of our original and then eventually multiply by the answer with 1 sig fig?
So your conversion factors don't count here because they're like exact numbers. Yes. Unless your conversion factor is measured, which we'll see coming up, like with density, but that has, yeah.
So conversion factors don't affect sig figs?
Right.
Oh.
Could you do it if it was going from inches to meters to millimeters?
Okay, can I show you the work?
Yeah.
Okay, so A would be 20 inches. Yes. So with this way, 507, 6142.
And there you have meters over meters. Which one is supposed to be a millimeter?
Oh, sorry. There, yeah.
Okay, I did that at first, but I got a totally different answer.
Enter it in your calculator again.
Oh, I wrote down the wrong conversion factor. I'm confused. I did it twice and it just.
Okay, so 20 divided by 39.4
Oh, there's the
times
problem.
1,000. And then you end up with 507.6, blah, 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 blah.
What if instead of doing 1 millimeter, or I mean, instead of doing the 1 meter has 1,000 millimeters, what if I did 1 millimeter has 0.001 meters? And then just,
Okay, you're saying what? Your conversion?
because I was thinking that we had to have like whatever unit we're trying to go to is what has the 1.
Mhm.
So I was like, okay, well, in 1 millimeter, how many meters are there?
Mm-hmm.
Which is it 0.001 or 0.000?
Okay, so in 1 millimeter, so 1 millimeter equals, so you're going to go 3 to the left. So 1, 2, 3.
So it is 2 zeros.
Yes.
Okay.
I really like, I'm not such a big fan of writing our conversion factors like this. Not that it's wrong, it's just harder to think about, you know what I'm saying? Like if you have 1 centimeter equals 0.01 meters, it's not as easy to grasp. But if you have something like 100 centimeters equals 1 meter, then you can think, oh, when you have 1 meter, there are 100 centimeters.
So using the base unit as what you look at as a 1.
Right. So
Okay.
the, yeah. Okay. Questions? The best thing you can do for these problems is to practice, 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 and you will be amazed at how you'll do a problem one day, the next day you come to it, you have no idea what you've done. You don't remember how to set it up, you don't remember anything about it. You just have to keep doing this again and again. So on the next page, I have more practice problems. So use the table or the box on page 21. You may need them for page 22. But I just want you to keep working on these. Don't panic. Just keep steadily working through these. And then I'll go through these answers and solve them with you. But I'll be kind of wandering around, looking over your shoulder. Don't panic when I look over your shoulder. I'm just trying to help you too.
So really I'm solving for meters cubed.
Right.
So you're saying to eliminate the grams.
Mm-hmm.
Okay. That means I need 1 gram. 1 over 1 gram. So I could eliminate the grams. And then I would need
Yeah.
centimeters squared.
So with number 5, you can work it several ways. Did a lot of people use the conversion factors that were given on this paper?
Not yet.
Not yet, okay. Or you could have used the ones that I had in the note pocket too. So if you use the ones that were on this, the fundamentals of math kind of conversion equivalence, you start off in liters. This is your solution map. And you're trying to get to cups. So you're going to go from liters to quarts, from quarts to pints,
Well, it gives you the cup.
and then pints to cups. And did you find a direct one?
Well, I went from liters to gallons to quarts to cups.
Liters to gallons to quarts to cups.
Just
Yes.
because it gives you the cups per quart. So I figured.
Yes. So several ways to work these. Okay. So let's just do 7.75 liters. That is, so 0.946 liters is 1 quart. 1 quart is 2 pints. 2 pints, or sorry, 1 pint is 2 cups. Liters, liters, quarts, quarts, pint, pint. So now you're in cups. So you're going to, anything that's on the bottom, you're going to divide by. Anything that's on the top, you're going to multiply by. So 0.75 divided by 0.946 times 2 times 2. Okay, so end up with 3.17124. What are the units?
Cups.
Cups. Very good. How many significant figures? 2. Yes, excellent. So 2 sig figs here. Means we need to have 2 sig figs here. So what do you end up with?
3.2.
3.2 cups. Good. Sorry, this is so blurry. 3.2 cups. Questions on that one?
I was wondering where you found that 1 quart was converted to 0.946 liters. Oh, it's on that worksheet. I feel like I looked up and down everywhere for that conversion. I couldn't find it. Okay. No, thank you.
I have a question. I think my sig figs are getting messed up when we do the chains because I always try to use that rule we have where it's only to the smallest sig fig on the last mass 1, so if it's 2 cups as a factor, I always try to make it 1 sig fig then, because then that's, so that would be 3 in that case, but if you don't use that
Because
last
it's an exact number, so it's not a measured. So it's like this is exactly 2 cups and 1 pint. So you always base it off the first one. Good. Okay, now, so Angelo, you had a question about number 6. Okay, so number 6, you're given 200 grams. You also have a conversion factor. Well, I'm going to put 2.70 grams over 1 centimeter, 1 cubic centimeter. Now, when you write it like this, it does make it a lot easier. Grams over instead of grams slash. It really, now you can kind of see, this is kind of, I like to work with numbers, you know, and so like you can see now you have grams and grams. How can you get them to cancel out? You flip, right? What? Go ahead.
Why did you use the 2.70?
It was given. It was in the problem. I haven't used it yet. It's just something that was given. Now, not everything that's given needs to be used. So you need to watch out for that. But in this case, we're going to use it. So what are we trying to find? Good. Cubic centimeters. Good. Okay. So between these two given numbers, and a lot of students will freak out. Oh my gosh, I don't know what's going on here. I'm just trying to take chemistry to get to X, Y, and Z. This is some sort of awful torture, right? No, I hope it's not that way. So you know, the panic will set in, and like, oh my gosh, my future. I just see it going. Right. Live in a van by a river. No, not gonna happen. Don't panic. So, just kind of step back and look at this. And you know, a lot of this is like puzzles. You're trying to put things together, get things to fit. So you have these two given things. You're asked for cubic centimeters. You have cubic centimeters right here. You have grams here. So it's just a matter of flipping it and setting it up correctly. So our solution map, you're going to start off in grams, and you're trying to get to cubic centimeters. You have a conversion factor that goes directly from grams to cubic centimeters. It's right there in front of you. But if you get busy panicking, you won't see it. So we do have a conversion factor that goes directly from grams to cubic centimeters. So my conversion factor is the one that has 2 units. So this is my conversion factor. And this is my starting quantity. SQ is for starting quantity. So it's just a matter of setting it up. So I have 200.0 grams. Make sure you put all those zeros, because how many sig figs does that have? 4. Excellent. Now, what am I going to do with my conversion factor? Am I going to leave it as is, or do I need to flip it?
You need to flip it because you need to cancel the
Yes, very good. We need to flip it. So 2.70 grams, 1 cubic centimeter. Your grams cancel out. So 200 divided by 2.7. How many significant figures do I have? 4. Okay, so we have 4 sig figs here. Now Jay, this is going to drive you crazy, because this is actually a measured quantity, our conversion factor. It's called density, mass per volume. Since this is a measured number, we are going to take it into consideration for significant figures. We'll have density problems coming up. So right now, based on what you know, if you put 4 sig figs on this problem, I would accept it. I wouldn't think, but I'm going to put a little asterisk by this. This is density. It's a measured number. Sig figs matter.
Is that, what do you mean by that? Sig figs matter?
So how many sig figs are in this?
3.
3. So now my answer can't have more than either of the original numbers. Didn't matter before because our conversion factors were exact numbers.
It doesn't matter now.
But it matters now because you're dealing with density.
So it should be 74.1.
74.1. Good.
Do you recommend doing it that way rather than the cross multiplying dividing?
I do have a preference for this way, but I definitely have had students who do the cross multiplying way. You know, so I think if you find yourself getting the correct answers, you can keep doing that way. But if you ever find yourself where you're just getting really tripped up, then I recommend doing it this way. It is pretty standard with chemistry problems that we do, straight across, and especially when you get into like Gen Chem, where you're taking grams and you're converting it to moles and then other moles and then molar masses are involved. So, yeah. But if it works for you now, you understand what's going on. Other questions? All right, this next question. It might look like, oh, I can do this. This is just the prefix ladder. I remember, see, centi, milli, micro. Centi is 2, milli is 3, micro is 6. Oh, I can do this, no problem. So let's go through. You're given 0.25 centimeters squared. You're asked to find micrometers squared. So our roadmap, you can do this 2 ways. You can go centimeters squared to micrometers squared, or you can go centimeters squared to meters squared, and then back to micrometers squared. So let's write out our starting quantity. Now, when you say centimeters squared, what is that the same as? Centimeters times centimeters, right? Okay, so you could write it that way. Okay. Well, if we don't write it this way, you might just be tempted to do the conversion once. So I'll put this over 1. And I'm going to go centimeters to micrometers. I like that. So I'll say, okay, go here. So 1 centimeter. So it's going to be 6 minus 2. It's going to be 4 to the right. So 4 to the right. 1, 2, 3, 4. So 10,000 micrometers. So that's my conversion factor that I'm going to use for this row. So 1 centimeter equals 10,000 micrometers. Now, if I stop right here, I'm done. my units will be what?
Centimeters.
Yes, crazy.
Well, but it doesn't have one single unit provided.
It's you are in between. So you're not completely done. That's why I wanted to write out centimeters squared as centimeters times centimeters. It's very easy to kind of just convince yourself, oh yeah, it works out. But it doesn't work out because we are in strange, crazy units. Centimeters, micrometers. So if you ever measure anything, and you know, because this would be like an area. So I asked, it would be weird. So we need to do one more conversion. How are we going to convert that last centimeters to micrometers? Repeat it. Now you could put a parentheses around here and put a square. So that would mean multiplying it twice, or you could write it out like this. Now, what are our units? Micrometers squared. Micrometers, micrometers. Good. So, you're going to do 0.25 times 10,000 times 10,000. Okay, so what did you get? 25 million. 2.5 times 10 to the 7th micrometers squared. Good.
So it is necessary. You can't really just move the decimal.
You know what? You could move the decimal if you wanted to. You would just have to do it twice. You move it 4, you move it 4.
Okay.
And if it was like a cubed unit, 3 times.
Is it possible that, because I didn't square it, if I just got 2,500,
That's
and then
incorrect.
and
Oh,
then I just squared my answer down, but I get the right answer?
no. If you squared your answer, then you
I
would,
just write that over. I don't know.
because 2,500. What is this? What did you say?
We were talking about the stress factor and how we're eating because you're stressed.
You want to eat. No, you won't get the right answer if you just square it. We're going to have to incorporate some exercise or something to relieve your stress.
We have fruit, vegetables.
No, I know. You guys are eating very healthy back there. Yeah. That's not my go-to food of choice when I'm stressed out. Chocolate.
During the exams, you get a little time pile.
Just eat your breakfast.
Only problem is that I need a
How
little.
many microns of chocolate did I just eat?
What's that?
I was saying, how many microns of chocolate did I just eat?
Jay will calculate it for you. Take it easy on the caffeine too with chemistry. I mean, caffeine's good for chemistry, but too much will put you in the panic state, the red zone.
That's why I'm never doing coffee.
Yes, that's good. That's a good idea. Or my husband, he teaches here too. One time he had a student who had several of those Red Bull energy drinks before a test, and they were having like heart palpitations.
Strokes.
I know. Why don't you just sit down for a while? And chill out, but yeah. So caffeine can be a good thing, but in moderation, for sure. So and I had a student last semester. She was super nice but super wound up about chemistry, and she would just drink. I would ask her how many pots of coffee I drank. You can always tell. So. Okay, any more questions about number 7? All right, let's work. Number 8. use the conversion factors from that box on the previous page. Try to set this up the way we talked about when you see per. So just try to go about it the way we've been working it. You can do it. Okay. So for this last problem, you're given 85 miles per hour. You're trying to find kilometers per hour. I'll find out. So you got miles. So that hours don't change at all. So your denominator is just along for the ride. It's not going to get converted at all. And then you're going to get, but you're going to change your numerator. So using the conversion factors that I have written on that table, miles to feet, feet to inches, inches to meters, meters to kilometers. Okay? Or you can do the one step like you did. What was yours?
Meters to kilometers, or miles to kilometers.
Or miles to kilometers. Perfect. Just one step.
Where'd you find that conversion?
I
Well, I found it on a white sheet. It's on
Oh, you found it on the white sheet?
Yeah. I found it, but it wasn't exact.
No, it's an approximate.
Oh,
It's
yeah.
1.61.
Well, let's see. I'll work it out the long way, and we'll figure out.
There is 1 kilometer is 160 miles.
Okay. So, in 1 mile, 5,280 feet.
Something went horribly wrong with my math.
What'd you get?
An incorrect answer that I don't even know how to say.
Is it like something octillion?
It's like a really big number, and I know kilometers are smaller than miles. So, it doesn't make any logical sense. But we set our problems up the same.
So it could be an entry error.
Maybe.
Okay, so let's do it. So 85 times 5,280 times 12 divided by 39.5 divided by 1,000.
39.5?
4, sorry. So I entered 39.4, so
Got the same thing.
136.69.
That's like 136, 690,
you, I bet you.
Well, I mean, it makes sense if I'm looking at it, because I multiply everybody on top, and then, oh.
You multiply
That's
by.
what I did. I have these two flipped. How does yours work? Because you took yours. Oh, I did it that. These last two guys, I mixed up that.
Mhm.
That's what I
That is a very easy thing. So what did you have? You had 1,000.
1,000 kilometers over 1 meter.
Yes. I see this a lot. So be careful with this. It comes. Students get it, and then it's like, no, that's not right. A kilometer is bigger than a meter.
Yeah.
Okay, so just watch out for that one. Now that you've done it now, you know what you'll be on the lookout for. Okay, so 136.69 kph kilometers per hour. How many significant figures do you use? 3.
3. Oh, 2.
No, 2.
3? 2?
And that
2. Yeah.
2. So then what does that round to?
140.
140. Good.